Comparison of two functions. The functions may be time functions or they may be a space functions. So functions, mathematical functions. If suppose I have one function that is n square and another function is n cube, I want to compare them to know which one is bigger and which one is smaller. So which becomes an upper bound and which becomes a lower bound. So for comparing these two, I don't have to check anything. Directly I know that this is smaller and this is greater. But if at all I have to check them, I have to prove, then how I can do? One method is I can sample some values. For example, if I take n as 2, then this is 2 square, right? So it is 4, and this is 2 cube, this is 8. So 4 is smaller than 8, so 8 is greater. If I take it as 3, then 3 square is 9, and this is 3 cube is 27. So yes, 27 is greater than 9. If I take 4, this is 4 square, it is 16, and this is 4 cube, this is 64. So I have sampled 3 values. That is enough for me to observe that this is always greater than this one. So yes, this is smaller than this one. This is one method of checking whether functions are compared. This is one method of comparing two functions to find out which one is smaller or greater, or are they equal. Second method is apply log on both sides. Apply log on both sides. Log n square, log n cube. Then this becomes 2 log n, and this becomes 3 log n. Now this is log n, this is log n, they are same only, but this is 2 times, that is 3 times, and definitely this is less than that one. So second method is apply log on both the sides to find out which one is smaller and which one is greater. So if you have some complex functions, then this is useful. This is a known function only, so I am taking a known thing to make you understand what is the method of checking them. So 2 log n, so I should check exact values. 2 log n is less than 3 log n. So for applying logs, you should know some formulas for log. So let me write some formulas here. Log a into b is log a plus log b. Log a divided by b is log a minus log b. Log a to the power of b is b log a. If you have any power here, that will come this side. It will become coefficient. A power log b base c is b power log a base c. Right? So this log value can come as a base here if it is in power. And a power b is equals to n, then b is equals to log n base a. These formulas must be helpful for solving log problems. So now the objective is to compare functions. So I will write few functions and let us compare them and find out which one is greater and which one is smaller. Here I have 2 functions. Let us find out which is greater. Compare them. So f of n is n square log n, g of n is n log n whole to the power of 10. So power of 10 is greater. So it looks as if that is greater than this one. We know n square is greater. So now it will confuse. So if you are unable to judge which one is greater, right? If you are able to judge, then no need to do anything. If you are able to judge it perfectly. Then let us compare and find out by applying log. Apply log. So this is log n square log n, and this is log n log n, this is power 10. You open this one, this is log n square plus log of log n. As we know, log a into b is log a plus log b. So log a plus log b. Now this side it will be log n plus log of log n whole to the power of 10. We have used first formula. Now using the third formula there, this becomes 2 log n plus log of log n, and this is log n plus 10 is in power, so 10 log of log n. Now check this. This is the bigger term, this is the bigger term on that side. Now if you check two bigger terms, this is 2 log n and that is just log n. So definitely 2 log n is greater than this one. Now that is a 10n log of log n and this is just log of log n. So that is a smaller value, log of log n is a smaller value. You can take it as 2 rupees some paisa and 1 rupee some paisa. So paisa is smaller than rupees, right? So this is greater. So this function is greater than that one. So this is greater than that one. Now, second example. F of n is 3 n power root n and g of n is 2 power root n log n. Let us compare. So for comparing, I'll first write it as it is, 3 n power root n, and this is 2, and this is log n root n log n. So if you apply this third formula, then this can also be written as n power root n, and this is base 2 only, log base 2, here is base 2, it's always, by default, always it is base 2. So it is 2 power log n power n, right, n power n. Now, by using the fourth formula, what I can do is, this I can interchange with this one. So this will be 3n power root n, and that n power root n comes here, and whole to the power of log, this 2 goes there, so 2 base 2. Log 2 base 2 is 1, so it is power 1. So what's the answer? 3n root n, and this is n power root n. Now I have two functions. So I did not apply log without applying log. I have not applied log on both the sides, but I have used the formulas of log for solving them. Even you apply log also, you can get something. So now what do you see? 3 n power root n, n power root n. So if you see the term, they are same. This is just a coefficient. This is just a coefficient. It is just like 2n square and n square. Who is greater? They are equal. They are equal. This coefficient is ignorable, right? Asymptotically, they are equal. Value-wise, this is greater. Order of n if you write, big O of n square if you write, big O of n square, big O of n square. Asymptotically, they are equal, but the value-wise, this is greater than that one. So if you want asymptotic answer, then both are equal. Both functions are equal.